So example 6, use the factor theorem. So it says use the factor theorem to determine if the binomials given are factors of f of x. Use the binomials that are factors to write a factored form of f of x. So the question given, A. So we need to see if the binomials x minus 1 and x plus 3 are factors. So we're going to rewrite. So we're going to make them equal to x is 0. So x minus 1 is 0, so this is x is going to be equal to 1. And x plus 3 is 0, so x is minus 3. So the first thing we're going to do is divide by minus 1. By 1, sorry. So we're going to write our coefficients. We have 4, 21, 25, minus 5, and plus 3. And the last column will be our remainder column. So we're going to bring down our 4. 4 multiplied by 1 is 4. 21 plus 4 is 25. 25 multiplied by 1 is 25. 25 plus 25 is 50. 50 multiplied by 1 is 50. And minus 5 plus 50 is 45. 45 multiplied by 1 is 45, and add in the last column is 48. Now this is a remainder. Because it has a remainder of 48, it is not a factor. So we can say that x minus 1 is not a factor. So now we need to check the second. So we're going to divide by 3, minus 3. So we write 4, 21, 25, minus 5, and 3. So bringing down the 4. 4 multiplied by minus 3 is minus 12. 21 minus 12 is 9. 9 multiplied by minus 3 is minus 27. 25 minus 27 is minus 2. Minus 2 multiplied by minus 3 is 6. 6 minus 5 is 1. And 1 multiplied by minus 3 is minus 3, which is 0. So no remainder. So x minus 3 is a factor. So now we need to check and multiply it out. So we're going to bring down this. This is going to be 4x cubed. So we're going to write it in f of x form. So 4x cubed plus 9x squared minus 2x plus 1. So this multiplied by x minus 3. And we can say that there will be a 0 at x plus 3 because x is equal to minus 3. So this will be at minus 3, 0. So checking our function in Desmos, we can see that we have a root at minus 3, 0. Okay, so question B, use synthetic division to test factors x plus 4 and x minus 5. So x plus 4 and x minus 5. So we need to see if they are factors. So the first thing is just try to rewrite. So equal to 0 and to find the value. So we've got x is 4 and then x minus 5 is 0, so x will be 5. So first of all we'll divide by minus 4. So we're checking our function. We have power 3, power 2, power 1, so that's okay. We don't need to include any zeros. So we have a 2, a minus 1, minus 41, and a minus 20. So the minus 20 column, this is going to be our remainder. So we're going to bring down the values. So bring down 2. 2 multiplied by... Okay, so 2 multiplied by minus 4 is minus 8. Minus 1 plus minus 8 is minus 9. Minus 9 multiplied by minus 4 is plus 36. Minus 41 plus 36 is minus 5. And minus 5 multiplied by minus 4 is plus 20. So the remainder is 0. So x plus 4 is a factor. So now we need to check x minus 5. So we're going to use the depressed polynomial. So we're using, this is here, the 2x squared minus 9x minus 5. So this is called a depressed polynomial. So we'll just use this now to test for x is 5. So bringing these values down, we have 2, minus 9 and minus 5. And the last one will be our remainder. So bringing down the 2, 2 times 5 is 10. 10 minus 9 is 1. 1 multiplied by 5 is 5. And we have a remainder of 0. So remainder is 0. So x minus 5 is a factor. So now we just need to check. So x minus 5 multiplied by x plus 4. We said they are factors of the original function 2x cubed minus x squared minus 41x minus 20. Okay, so from our depressed polynomial, 2, 1, 0, this is going to be 2x plus 1. So this is also a factor. So that means we have 3 factors. So x minus 5, x plus 4, and 2x plus 1. So this is x is equal to 5, x is equal to minus 4, and x is equal to minus a half. So we can check using a graphing calculator that we'll have our zeros at these points. Okay, so putting the function into Desmos, I've clicked on our roots here, or the zeros, and we have minus 4, minus a half, and 5. So we can see that our answers are correct.